So basically, with this project, we first calibrate the mobile device camera and collect some images, and then we compute the pose of the camera with respect to the image, and which is done here in this function, and we get RNT, and then we compute the relative pose between cameras, which is done here, and we use this equation, and this equation is implemented in these two functions, and we store the RNT here calculated from step 3, and in here we calculate the relative pose, the RNT for each image pairs. And for step 5, we compute features matches between images, and step 6 for epipolar constraint. So it is implemented in this function. This is the match function, and the epipolar constraint is implemented here. And so we get the mask, and the mask is used here. And after we compute the feature matching, we need to compute the feature tracks, which is we want to know which features appears more than 3 times, and it is done here. We use a default dictionary here, and the key for the dictionary is the coordinates of the reference, coordinates of the key points in the reference image. So in here we compute that if it appears more than 3 times. If it is, we save this feature for the computation of depths in step 8. So we know all the features with at least 3 observations. We compute the depths using this equation, and first we need to compute the m. So we get the m here, and we then use SVD to get the depths, and then what we do is we use the depths and to times the original x coordinate to get the resulting coordinates, and then we use point cloud for visualization. And the result is here, which there is 2 clusters. One represents the object, the other one for the reference image. So this is basically all about the homework 4. Thanks for listening for my presentation.